Factoring quadratics. What we want to look at here is let's just kind of lead up to this concept, and then this concept of being able to factor quadratics and solve is going to be a very foundational skill you're going to keep on using in other ways. So far, we have already considered what is our linear functions, y equals mx plus b. And then we've also looked a little bit at a quadratic, but written in a general form, it's y equals ax squared plus bx plus c. So this is your general form. And when y equals 0, what we're able to find is our x-intercepts, our roots, our solutions, our zeros. You know, that's always your big goal, trying to solve for x, solve for x. In a linear form, when you just have x to the first power, you just start moving things around. We know how to solve for x. But when we get into these x squareds, it becomes a situation. So what we're going to do is we're going to process through how to solve a quadratic or how to solve for x when you have a power on it like this. The first way we're going to do this is by factoring. We're going to kind of ramp up as we go. When you're looking at factoring, first let's just look when your leading coefficient is a 1. That means you're looking at the situation of x squared plus bx plus c equal to 0. So that's just meaning that a, or the coefficient that's on your x squared, we call it leading because it's the highest power, it's at the front. In order to do this, what we're going to do is we're going to first, kind of step by step here, we are going to find the factors of C that add to B. And there's a whole process, but I just want to kind of write out some simple steps. Then step 2, what we're going to do is we're going to write as linear factors. And then step 3, you're going to set each equal to 0 and solve. This is known as using your 0 property. So let's just kind of use that as a basis for us and look at this example here. So what we want to do is factor and solve, or you can see we have a situation equal to 0, and it's not just x equals. If it had just been 2x minus 8, we can move stuff around. But because we have this x squared, we cannot move it around. First thing you have to do is get it into a general form where everything is equal to 0. And I like to line them up in descending order of exponent. Next thing you're going to do is you're going to look at the factors of C that add to BB. And I like to make a list. I have to go, okay, looking at 8, what will multiply to give me 8? And I start with 1 and the number. And then I go, well, 2 multiply to give me 8? It will. 2 times 4. Will 3 multiply to give me 8? It does not. And now I'm back at the bottom of my list 4. So these are all the factors of 8. Now, the fact that it's a negative 8, that means one of them in the pairing had to have a negative. So I'm going to now go throughout and I'm going to say, okay, I'm looking for what will multiply to give me the negative 8 and add to give me the negative 2. So I'm going to look throughout my list. I'm going to add them up. When I add those up, that gives me a 7. So that's not it. When I add these up, it gives me a positive 2, and I want it negative, so that means the negative should have been on the floor, and that would add to give me a negative 2. So next, I'm going to write it as linear factors. So I'm going to do my 2 parentheses. The reason I'm doing this is I'm unmultiplying it. So what would multiply to give me x squared? That's x and x. I think, okay, my factors were a positive 2 and a negative 4 equal to 0. And this is where your 0 property comes into play. We're going to set each equal to 0. If I have something times something to give me 0, that means either this was 0 and it zeroed out this, or this was 0 times whatever's here, and it still is going to end up in a 0 situation. So I like to draw a table and go, well, that means x plus 2 could have been 0, or x minus 4 could have been 0. So I'm going to subtract 2 from both sides to solve for that. So x equals negative 2. Or I'm going to add 4 to both sides, and I get x equal to positive 4. So you're going to see as we work through this situation, when we are solving a quadratic, we have the possibility of getting two answers, which is amped up from when we did our linear situation. Now, this is the case where my lead coefficient was 1, and this will work anytime I have a 1 here. I think about the factors of the back number, what will multiply to get the 8, and what will add to get me the 2. Another situation we're going to counter is, what about if the lead coefficient is not 1? Well, let's look at 2 examples and we'll go from there. The first example I'm going to look at and say, okay, well, I can see that my lead number on that x squared is not a 1. So maybe consider, or we could say first, look for the GCF. The GCF is the greatest common factor. So we're going to look at 6x squared and negative 3x and figure out what do they have in common. They both, looking at the 6 and 3, could be divided by 3. So that's going to be part of GCF. And then looking at the variables, x squared and x, they both have an x, and we take out the smallest of the exponent, which is x to the first. So this is our GCF, and we're going to factor this out of what was given. So I'm going to say 6 divided by 3 gives me a 2. X squared, take away 1x, gives me a singular x. Minus 3x, I'm going to take away the whole thing, but I'm going to have to leave a 1 as a placeholder. So we're just undistributing this. Now that I have something times something to give me 0, that means I'm going to draw my table and say, well, 3x could be equal to 0, or 2x minus 1 could be equal to 0. I'm going to solve these out. So dividing by 3, I just get 0. Add 1, I get 2x equal to 1, and divide by 2. So x is equal to 1/2. So this is another way that I could solve a quadratic. In this case, I had to factor the GCF and then solve. But you can see, again, I have 2 answers. The next way I want to look at solving, or factoring and solving, I'm going to do 2 examples. But you can see in both of these examples, this lead coefficient, or this number attached to our x squared, is not a 1. So we're going to have to work with this a little bit differently. So in order to factor and solve in this first one, I do always want to check for GCF, but 3, 4, and 15 do not have a number that will divide them all. And only the first 2 pieces have an x, so I cannot take the x out. So here's how you can work one where you have a number attached to your x squared. What you're going to do is you're going to multiply, this is my a, b, and c, so you're going to multiply a and c together. So I'll say, what is a times c? So I'm multiplying the front piece times the back piece, and that gives me 3 times negative 15, which is negative 45. And that's what I'm going to figure out. What are my factors of 45? That's 1 and 45. 2 does not divide 45. 3 does, and 15. 4 does not work. 5 goes into it 9 times. 6, 7, and 8 do not divide 45, so I know I have the complete list of factors. It is negative, so I'm just going to put a negative down the side here. Then, just like what we did previously, I'm going to look at my list and think what will add to give me this negative 4. Well, this adds to 44. This adds to 12. This adds to 4, but I need it to be a negative 4, so I'll put my negative on the 9. We did all this because what we're going to do is split this middle number. So I have 3x squared. So instead of minus 4x, I'm going to say plus 5x minus 9x minus 15 equal to 0. You can see if I put 5 and negative 9 back together, it'd give me the negative 4. Then I'm going to do something called factor by grouping. I'm going to look at the front 2 and factor like we did the previous example by GCF. They both have an x in common, so I can pull that out to give me a 3x plus 5. Looking at the back 2, they both have a negative 3 in common, so I can pull that out, again, leaving me with 3x plus 5. Now I have 2 terms being subtracted. You can see that 3x plus 5 exist in both of them, just like what we did in the previous example with x. So now we can pull that grouping out front. 3x plus 5, x minus 3 would be left over. These are the harder problems factoring, but this process that I'm showing you, and I'm going to show you again in the next one, is going to be the most direct, step-by-step way to always get there. Now I can set this equal and say, what is 3x plus 5 equal to 0? That gives me -5, so -5/3. X minus 3 equal to 0, which gives me +3. Let's do this again, and let's work with this next one. This next one is a little bit different because you'll notice it is not equal to 0. So the first step you always need to do is to get it equal to 0, so I'm going to subtract this 3 over. This gives me 2x squared plus 9x plus 4 equal to 0. Now, because this has a number attached to my x squared, we're going to take the same approach as earlier. So I'm going to multiply the front and back number, which gives me 2 times 4, which gives me 8. And that's how I'm going to create my list of factors. So that's 1 and 8, 2 and 4, 3 will not go into 8, so that's my list. Then I think of that list, what will add to give me 9, that's 1 and 8. So I'm going to split 9x into 1x and 8x. Bring everything else down. Then I'm going to factor by grouping. So I'm going to group the front two pieces and think, what do they have in common? GCF, they have an x in common. So I'm going to undistribute that x, so it gives me 2x plus 1. Plus, I'm going to group the back two, and they can both divide by 4. Again, dividing off the 4 gives me 2x plus 1. Now, my two terms have this large grouping in common, so I'm going to bring this grouping out front. So 2x plus 1 brought out front leaves me with x plus 4. And now I can set equal to 0 and solve. So 2x plus 1 equals 0. Just solving for x. X plus 4 equal to 0. So -4. These are going to take some more time. They are a little bit harder. I want to walk through all the processes. I've given you some problems to try in the homework, some additional help videos with the lecture and the homework assignment. Go and try what you're doing here and then go into the next part. If you would like some additional examples to work, here are those examples, and then I'm going to post the solutions in the instructor notes.